If you want to substitute the values of alpha and beta directly into this expression, this problem is going to take you forever. Welcome to Knowledge Base. In this video, we want to find the value of alpha squared plus beta squared divided by alpha cubed plus beta cubed, given that alpha is this and beta is the conjugate of alpha. If you put the values of alpha and beta directly into this equation, you are going to solve this for a very long time. So in this video, we want to use another approach, which is solving using identity. What I mean is that we are going to create, or we are going to use the identity for alpha squared plus beta squared and the identity for alpha cubed plus beta cubed. Let's dive right into it. For alpha squared plus beta squared, this is the identity we want to use. Alpha plus beta all squared is equal to alpha squared plus beta squared plus 2 alpha beta. If you take your time to expand this, you are going to get this. Now you can see alpha squared plus beta squared, what we are looking for here. If we make it subject of formula, it means this positive will cross over to become negative. And alpha squared plus beta squared will be equal to alpha plus beta all squared minus 2 alpha beta when this crosses over. So this is the identity we are going to use for the numerator. Now let's look for the identity for the denominator. Similarly, alpha plus beta all cubed will be equal to alpha cubed plus beta cubed plus 3 alpha beta into alpha plus beta. This is an identity as well. You can, if you memorize this identity, it is fine. But if you don't know it, you can take your time to expand alpha plus beta all raised to power 3. If you do that carefully, you are going to arrive at this. Either you memorize this or you know how to expand it yourself. We are looking for alpha cubed plus beta cubed, which is the denominator. If we make it subject of formula, it means every other thing here is going to transfer to the right hand side and this will become negative. What it means is that alpha cubed plus beta cubed equals alpha plus beta all cubed. This crosses over to become minus 3 alpha beta into alpha plus beta. So this is the identity we are going to use for the denominator. Now let's look at the identities carefully. We have alpha plus beta, we have alpha beta, alpha plus beta, alpha beta, alpha plus beta. If you look at these two carefully, you find out that just two terms are reoccurring, alpha plus beta and alpha beta. What it means is that we can get a value for alpha plus beta and alpha beta, we would have solved our problem. So we are going to do that now. Let's start with alpha plus beta. Remember, alpha is 2 minus root 3, so we have 2 minus root 3 plus beta is 2 plus root 3, the conjugate of alpha, plus 2 plus root 3. It means alpha plus beta will be equal to 2 plus 2 is 4, minus root 3 plus root 3 is 0. So alpha plus beta is 4. It means anywhere we find alpha plus beta, we are going to put 4. Now let's find the second one, alpha beta. Alpha beta is simply the product of this and this. So alpha beta is 2 minus root 3, all multiplying 2 plus root 3. Looking at this carefully, you would have understood that they are conjugates and it forms the difference of two squares. By difference of two squares, it means alpha beta will be equal to 2 squared, which is 4, minus root 3 squared, which is 3. 4 minus 3 is 1. This is the difference of two squares. We have done several videos on difference of two squares, so if you don't understand this, you might want to refer to one of our videos on difference of two squares. Now we have alpha plus beta and alpha beta. We can now solve this problem given to us. So this identity, or this expression, alpha squared plus beta squared over alpha cubed plus beta cubed will be equal to this, representing our alpha squared. As you can see, alpha squared plus beta squared is this. So I've put it at the numerator. Alpha cubed plus beta cubed is this. And I've put it at the denominator. Now, all we need to do is to put in the values of alpha plus beta and alpha beta, so that this expression becomes 4 squared, because alpha plus beta is 4. You square that, minus 2 alpha beta. minus 2 times 1 because alpha beta is 1 all over 4 cubed because alpha plus beta is 4 minus 3 alpha beta is 1 times alpha plus beta is 4. So we have 3 into 1 times 4. Solving this further, we have 4 squared is 16. 16 minus 2. 2 times 1 is 2. 16 minus 2 will give us 14. 4 cubed is 64. 64 minus 3 times 1 is 3 times 4 is 12. So 64 minus 12 will give us 52. So this expression is simply equal to 14 divided by 52. 2 is common to the numerator and denominator, so let's reduce to the lowest fraction. That brings us to the final answer to be equal to 7 over 26 because 2 into 14 will give you 7, 2 into 52 will give you 26. So this is the answer to this question. Very simple, straightforward. What you needed to do is to know the identities. If you don't know them offhand, you can simplify them yourself. Alpha plus beta squared. Simplify it yourself. Alpha plus beta cube. Simplify it yourself, you're going to get to this. Otherwise, you can go the memorization way. This is a good way to solve this problem. If you understood this, I want you to try this simple one as well. So this is what you're given. Try this. Solve 2 alpha beta plus alpha square plus beta square. Given this same expression, given that alpha is this and beta is this, solve this and put your answer in the comment section. Thank you very much for watching this video. If you love it, please like, share it to your learning colleagues and friends, and drop your comments in the comment section because I'll be there waiting for you. Please follow our page if you have not done so. And if you are watching our video on YouTube, endeavor to subscribe, and that way you keep encouraging us in making interesting content. Thank you for watching.